For this next section, this is the quantitative portion about the energy. So we're doing some calculations. One of the things you got to do is make sure that you read. It says sketch the temp time graph. Some people will claim, well, I can do it without it. If the directions say to sketch it, you're going to need to sketch it. This part also says label which phases are present in each portion of the curve. So what might look like on this one? A 280 gram sample of ice at negative 30. So I'm going to need a negative 30 over here. It's going to heat it to steam up to 155. I'm supposed to understand that that's going to raise in temp as we heat it until it gets to 0. And I'm going to draw a plateau where it changes phase. Then it's going to raise in temp again until it gets to 100. And then it's going to plateau, and then it's going to raise up to 155. I don't need those to be fully to scale. I can just see that there are 1, 2, 3, 4, 5 sections. I'm supposed to label then which phases. This is just solid because it's below 0. Between 0 and 100 is liquid, and above 100 is going to be a gas. So when the transition areas, that means I'm going to have both liquid and gas. And then the other transition area down here, I'm going to have both solid and liquid. Next thing is I'm supposed to calculate the amount of energy. Since I see 5 distinct segments, I have 5 different numbers I have to add up. Every one of them is going to be based on 280 grams. 280 grams. So I like to just frame it by getting things set like this. Now certain parts, like here, here, and here, that's a mess, so I'm going to back that up. All of those have a slope. And so all of those are going to be MC delta T. MC delta T. You do not have to write these little notes. I'm just trying to help anybody understand. The other two kinds of parts, here, where it's melting, and here, where it's boiling, I'm going to have to use these words, vaporization and fusion, and I'll need those numbers in a little bit. If it's melting, it's fusion. So let me go back here. This part was melting, so it's fusion. This part was boiling, so it's vaporization. This helps me know which numbers to go get. In fact, I might even just start with the fusion and vaporization. Fusion, heat of fusion, every gram requires 334 joules. So that's going to be times 334 joules. For vaporization, every gram requires 2,260 joules. So I'm going to write times 2,260 joules there. The other portions are M, C, delta T. The M I've already done for every one of them. It's the same 280 gram sample. It's the C's and the delta T's that are going to be different. This first section, that's when it's a solid. So the specific heat of a solid ice is 2.1 joules per gram degree Celsius. 2.1 joules per gram degree Celsius. Change in temp to get from negative 30 up to 0 is a change of 30 degrees Celsius. The next MC delta T is this part. That's liquid water, because anything between 0 and 100 is liquid. So when I go get this number here, it's this number. Liquid water is 4.18 joules per gram degree Celsius. The change here is from 0 up to 100, which is a change of 100. Finally, the last part, we're dealing with a gas that's heating up. Specific heat for that gas, which is C, will be steam, 2.1. Times 2.1 joules per gram degree Celsius. And the change in temp for that gas is going to be from 100 all the way up to 155. That's going to be a change. I would multiply all these numbers out. You don't need to watch me do that. I would add them all up. And if you did that right, you will get that one correct. Next. The next one is a similar. I have to read, draw the heating cooling curve, whichever it is. This one looks like it's going to be a cooling curve, so it's going to go down. I have to include the numbers, and I also have to put the phases that are present. Sounds like it's starting at 30. Just arbitrarily declare this at 30. I know liquid water will cool only until it gets to 0, and then it's going to freeze. Then it's going to cool down a little bit more, all the way down to -5. Since it's above 0, this is going to be liquid. Since it's below 0, down here, it's going to be solid. And in the middle, it's going to be solid and liquid. Liquid and solid. Doesn't matter which order. This tells me that it's a 1, 2, 3-step process. 1, 2, 3-step process. So when I look at this 150 gram sample, I'm going to write 150 grams, 150 grams, 150 grams. If there's a slope, like right there, it's an MC delta T. If there's a flat spot, then it's a phase change, and it's going from liquid to solid. That name of that is called a fusion for freezing. So this will be fusion. One more slope, that's an MC delta T. First slope is liquid. Liquid is 4.18 joules per gram degree Celsius. That changes from 30 all the way down to 0. That's a change of 30 degrees Celsius. Flat spot, heat of fusion. That number is 334 joules per gram. And the last slope. That's solid, and so I'm going to use the specific heat for solid, or ice, which is 2.1 joule per gram degree Celsius. And the change in temp is only going to go from 0 to -5. That is a change of 5 degrees Celsius. Once again, you add up, or you calculate all them out, a lot of multiplication. You add the 3 of them up. Again, you don't have to watch or listen to me do math.